Hello there children. So in the last video, we have learned about series circuit as well as parallel circuit. Normally, we use parallel circuit in our household because if one light bulb blows, other will still be working. In today's lesson, we will learn what is current, voltage as well as resistance. The objective of this video is to allow you to explain what it meant by current, voltage as well as resistance, and importantly, state their units. Then you are going to learn what is a voltmeter as well as a ammeter. Voltmeter and ammeter. Then lastly, we will learn how to draw and interpret a circuit diagram. Because after the initial part, you should know what is an ammeter as well as a voltmeter and a resistor as well. Okay, let's begin. So what is current? So current is something that flows from the positive end to the negative end. If you ask me, I don't understand why we are learning current because it doesn't exist. But anyway, so unlike electron that flows from negative end to the positive end, current flow from the positive to the negative end. So current will flow from here to the light bulb, then back up and back into the battery. So current will flow from the positive end to the negative end. So write this down. Now, just now, if you didn't hear wrongly, I whispered that actually current doesn't exist. So what happened is this. At the beginning, people thought that, oh, electrical charge actually goes from positive to negative. But later on, they discovered that, hey, this is not true. However, because there are a lot of circuit diagrams that have been drawn and calculation that have been done is on the basis that the current flow from the positive end to the negative end. So they decided to leave it because there will be just too much changes to rectify the mistake. And if you ask me, there's something like why humans have blind spot. Of course, you don't understand what I'm talking about, but never mind. Let's move on. So how do we measure current? We measure current using ammeter, and you can see one down here. So ammeter is supposed to be connected in series. There's a positive terminal down here, as well as a negative terminal. If you have downloaded the PHET app, which you saw in the last video, you can actually play around with it. So this is the app which you have seen in the previous video, and you can play around it because it have ammeter as well as voltmeter. So let's look at ammeter first. So ammeter, as mentioned, it should be connected in series. Now look at what happens if I connect it in parallel manner. Let me close the switch. Boom! Then fire will occur because the electricity wouldn't flow through this part because of something known as resistance that you will learn later. So let me open the circuit. Let me remove the wire. And let me try to connect this in, what you call that? In series. Oops. Okay. Maybe I should connect this like that. Okay, now. So like this, it will be in series, one after another. So 9 ampere. Ampere is the unit. So look at what happened if I go and add one more battery. Okay, let me remove this part. Let me add a battery. Okay, just now it was 0.9 ampere. Now you can see that the current that is flowing through increased. Why is this the case? Because now there are three batteries, meaning the voltage is higher. So voltage can cause the current to increase. Okay, please copy this down. Ammeter is connected in series. Alright, this is the important thing that you have to take note. Next, what is also important for you to copy down in your notebook is the unit for current is ampere. It's pronounced as ampere. And how do we write it as short form? Is we just write a A. Just like we do not spell kilogram, we write it as kg. And ampere, we write it as A. So if the current passing through the ammeter is 2 ampere, we write it as 2A. As simple as that. Next, we talk about voltage. So voltage is provided by the battery, and it's not surprising, battery will provide the force for the current to flow. Another name for voltage is electromotive force, which is how motivated the electrical charge is likely to move from one terminal to the other. So the higher the motivation, the larger force or the larger voltage that it will be provided. And to measure voltage, we use a voltmeter, and voltmeter must be connected parallel to the component or the light bulb that we are measuring. So placing a voltmeter here will let us know what is the voltage that is running through the light bulb. So earlier on, we have seen our ammeter in action. Now let us take a look at voltmeter. So for a voltmeter, we are supposed to connect it in a parallel manner, which is like this or like this. Then for this circuit, it will just be like this or like this. Or if I want to measure the whole thing, I connect here and here. Oops, like that. Okay, so for a voltmeter, you are supposed to connect it in a parallel manner rather than series, because it wouldn't work. Why you need to connect it in parallel is because we need to measure the force over here as well as the force over here, so we can tell how much force is needed to push the current from here to here. And voltage across these two light bulbs is different from the voltage across one light bulb, because if I measure from here to here, it has to push through two light bulbs, whereas from here to here, only one light bulb. So let me set this up and close the switch. You can see that we are getting a reading of 18 volt. And what will happen if I increase the number of battery? Let me include one more battery. Okay, now you take a look. Oops. Now you take a look, the voltage increased to 26.998 or 27, and this is the voltage across these two light bulbs. if I only want to measure the voltage across one light bulb, what I do is like this. So it will measure the force needed to push the electricity from here to here, which is 23.5 volt. And if I want to measure here, it's also 23.5. And together they will be 26.998 or 27. So this is how you use a voltmeter. You connect it in parallel manner. And the same goes for a parallel circuit. If I want to measure this light bulb, I measure like this, 18 volt. Over here is also 18 volt. Over here, as well as over here, is also 18 volt. So this is how you set up a voltmeter. You need to set it up in a parallel manner. So putting a voltmeter here will allow us to know how much force it takes for the electrical charge to move through this light bulb. And again, you can play around with a voltmeter in the PHET app. The unit for voltage is called volt, and if the battery is 1.5 volts, we write it as 1.5 V. As seen in the earlier demonstration in the app, to get a higher voltage, we can join two or more battery. Another name for battery is called dry cell. Okay, so dry cell is battery, and normally they are 1.5 volt. And to get a higher voltage, we can connect them together. The positive end must be connected to the negative end as shown down here. So you can see the positive end is connected to the negative end. Positive to the negative. But if we connected wrongly, let's say we have a battery down here. So this side we know is a positive, this side is the negative end. Then you have another battery. Positive end and negative end, like this, it wouldn't work. Alright? You need to connect positive to negative to allow the current to flow through. Lastly, let's talk about resistance. Resistance is something that opposes the flow of current. So oppose the flow of current. It is something like friction. So all electrical components have resistance. Some have higher resistance compared to others. And it's because of this high resistance that our light bulb or the filament in the light bulb have, which allows it to give out light. So down here we have two circuits. A circuit have a higher resistance because there are two light bulbs that oppose the flow of the electrical current compared to only one light bulb in the circuit B. So what you can imagine is like, let's say there's a route for the car to go through. So imagine that this is car, then it's going through. Then there's root block down here. So when there's root block, the movement will be slower. So I can increase the number of root block, then there will be more resistance to the movement of the current. You can also understand what is resistance by thinking about flowing water or flowing current. So water will flow quicker when there is nothing. So this is when it is low resistance. Then let's say something is blocking, but the water can still flow through. So rather than flowing straight, it will go up, then it will continue flowing. So the flow will be slower because there is higher resistance. And we can actually control the resistance in a circuit by using a resistor. So copy this down. Resistor provide resistance, and there are two types, fixed as well as variable. What do I mean by fixed? Fixed resistance means that the resistor in the resistor cannot be changed. While a variable resistor, variable means can be changed. So the resistance on this variable resistor down here can be adjusted by moving this slider. The slider is down here. You can move left and you can move right to change the resistance. Again, resistance is how much force that is opposing the movement of the current. So now that we know our resistor, how can they be measured? So we can use a multimeter set to resistor mode to measure, but more importantly is the SI unit. Unit is always important because it's written in your syllabus outline. This multimeter, if you look at the objective, you don't really have to know. You just have to know about it in upper set. But honestly, I think upper set also don't really have to know. But anyway, important thing is also the unit, which is pronounced as ohm. Ohm, 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 ohm. And if a resistor have a resistance of 10 ohm, we write it like this. This is the unit of ohm. I can write it bigger. It's like that. Ta-da! So why do we use resistor? So resistor is used to control the current that is flowing through electronic appliances. When we say someone get electrocuted, it is due to the current that kills the person, not the voltage. Because it is the flow of electricity that can kill a person, not the force. So why is it important to obtain the proper current? Is because in other country, the voltage that is supplied is different. So the output current will also be different. So in other country, it could be 120 volt. But in Singapore, it's 220 or 230 volt, if I'm not wrong. So if you are buying something online from other country, make sure that they are compatible with the current as well as voltage rating. Because if the current is not compatible, the electronic gadget might get fried by the electricity. Therefore, it's important for us to get an adapter. Therefore, it's actually important for us to get a resistor to actually control the current to maybe reduce or increase the current so as to prevent us from spoiling the electrical appliances. Finally, this is some symbol that you can find in a circuit diagram. So why do we use circuit diagram is because it simplifies the drawing. It makes the drawing simpler. So just now you've seen me drawing battery, which is actually not very nice, and it actually takes how long to draw the battery. And instead, we just draw a battery like this. Okay, the battery is here. The positive end, you draw it longer than the negative end. Then you have wire coming out, just like that. Then voltmeter looks like this. Ammeter we also learn. Resistor looks like this. Variable resistor have the arrow. And I do not want some of you to tell me this thing is X-Men. Okay, this is not X-Men. This is a lamp or a light bulb. And some additional knowledge, I don't think this will be applicable, but sometimes the light bulb can be drawn like this. Dang, dang. Like that. Like this can also be a light bulb. Anyway, just copy this down and be familiar with each of the symbol, because you can see them in paper, in your exam paper, as well as other circuit diagrams, so that knowing this will help you to understand what is going on in the diagram. So over here we have example of circuit diagram. The first one on the left have a cell. A cell is, like I said, is just a battery, alright? Battery. Okay, battery is down here. That is connected to two light bulb. Here, 1, 2. Two light bulb in series. Then the switch down here, this one is the switch, which is open. So if they ask you to draw a circuit with a cell and two light bulb in series with an open switch, this is what you draw. Over here we have a circuit with one battery again, closed switch, and these two light bulb, are they connected in parallel or series? This is known as parallel circuit, because the electricity have actually two paths to flow. Alright, so this will be all for this video.